Thanks, Ron. Thanks, Tom, for the wonderful speech. My name is Bob Stoyanovich. I'm responsible for the solar power segment in North America. I've got Alex Levering in the audience. He handles it globally, so if we have questions as far as ABB goes, we can answer those, but we'd like to focus on the industry at this point. So I have questions in the crowd, and I'm going to repeat them for two reasons. One, so I can digest it, and two, so we can get it recorded. So what's your question in the back? So the question is to discuss the animosity between the utilities, specifically in Arizona. Really, the issue is that there is, I wouldn't call it animosity so much, but there is a battle over how much solar can be installed, who's going to own it, and the difficulty the utility has in implementing those systems. So we'll let Ron answer the question.
Sure. So the 30-second is we're talking about net energy metering, right, which allows you, when you generate extra electricity on your home, to sell it back to the grid. And our perspective is that you should get a full value, a retail value for that electricity, because I'm generating electricity on my home on a sunny day. I'm not using it all up because I'm at work. It's going to go into the wires and then going to go to my neighbor's house, Tom's house, and he's going to use it, and whatever excess continues on. So it is a retail electricity product. It's not a wholesale product. But as the market grows, especially in Arizona and Southern California and Hawaii, you're seeing a greater and greater percentage of the electricity come from DG. And so if I'm generating 93% of my electricity, that means my electric bill is a lot lower than what it used to be before I put solar up. And my utility isn't necessarily a big fan of that. Their arguments now are to kind of step back and say, well, we have fixed costs, and we planned these fixed costs years ago before you put solar in. We need to pay for those fixed costs. So what APS did in Phoenix was to come back and try to put effectively $100 a month surcharge on anybody who wanted to go solar. Well, that's the full value of the solar that you're going to produce in the case of course of that month. Now, we worked with APS, we negotiated it down, and ended up being a much smaller level, but ultimately that fixed charge rate was something that was very aggressive by APS and that we needed to oppose. Now, we're not opposed to recognizing that there is a fixed minimum cost that utilities have to operate, but that should be applied over all ratepayers, not penalizing the solar ratepayers. Because when you start thinking about it, it's not just solar, it's future technologies, it's energy efficiency, it's all of the home automation things that are going to make your life more efficient and more effective. So instead of coming up with different rates to penalize you because you put in energy efficient lighting, and you because you went solar, and you because you're now using a fuel cell at your house, looking at a rate design structure that makes sure the utility can keep the lights on and continue to operate, yet also encourage more innovation into the marketplace is what we're looking at. So in Arizona, obviously it blew up. It got very ugly and continues to be ugly with SRP and TEP's programs, which are, again, a huge penalty on people who want to go solar. But this is something that we're seeing across the country, as the Edison Electric Institute has identified distributed generation as one of the biggest threats to the utility business model. They did it in a paper 2 years ago, and since then there's been a very collective effort to try to put these programs in place. But ultimately, we want to get past Arizona. We want to have a constructive dialogue with the utilities. We want to figure out the right rate design that encourages more technology development, more competition within the marketplace, but a rate design that allows everybody to thrive.
What's going on? What can you give an update on where we're at with that?
Sure. So there's 20 separate net metering rate design issues across the country going on right now, and we're working through them one by one, which is tough, and unfortunately it's very aggressive. It's very what's the word? It's not necessarily based on where we need to go. It's trying to quickly fix a problem and penalize a group today. And where I think kind of the rate design structure goes is more, again, towards that minimum bill type of perspective that is applied across all ratepayers. It exists in a number of states, and it works very effectively. It's not anything we're inventing just because of solar, but is something that doesn't necessarily is not applied around the country uniformly. So moving more towards that direction is what we're trying to do, but there are 20 separate rate cases or net energy metering issues that we're trying to resolve in the country today. So we'll see. Unfortunately, it's a state-by-state law, and even a utility district by utility district, so there's no federal approach we can take to it.
Tom, maybe you repeat the question. It's kind of awkward if we're going.
So the question in my numbers up there was the PTC included, and I believe, well, I should jump back up there. Honestly, that chart, I'm not sure for the LCOE. I can say with the PTC, we are at $20 per megawatt hour, sometime actually 19 for some of the PPAs out there with the PTC. So you take the PTC out and we're up above that. But in some high wind places close to transmission, 20, 19 or so dollars per megawatt hour with the PTC. And it's why the production tax credit for wind is important. I mean, it is driving down in some key parts of the country some very low prices.
What's the prices?
Follow up?
So when you say, during the so-called polar vortex from last year, you said, I've seen this stat before, $1 billion of savings. So is that $1 billion of savings net of the production tax credit, or is it include the
That includes the benefit of the PTC in there, yes. So it is, I mean, the PTC, that is factored in there, and it's compared to the price of wind, including the PTC, relative to whether it was gas or whatever for that period of time. Again, I would say the PTC is, for the wind industry, our form of tax support, tax relief. All other forms of energy generation get significant relief. And in fact, I didn't show it today, but I've got a bar chart showing the average annual subsidy for oil and gas up here, for coal, for nuke, and renewables is way low. In other words, the annual average subsidy for solar and for wind, for the PTC, the ITC, is a lot less than the annual average subsidy for all other forms of electric generation.
per unit or gross on a national basis?
Gross on a national basis. And I would also add, remember, I mean, they've had decades, I mean, back to the 1920s, 30s or whatever, and frankly, as industries, we need some time to develop, and we've said at least at some point, we don't think we need the PTC. We're not arguing for the PTC forever, but we are looking for it for a period of time such that we can get to a critical mass, to a critical scale, so the costs can come down and we can compete straight up. I haven't heard other energy sources say that as often as we are. Question being about offshore wind, what do we see as kind of the costs and the cost trajectory and the trade-offs offshore, onshore? So here's, at least from our view, quick summary. Yes, I mean, offshore wind in the United States and abroad, significantly more expensive than onshore. It's frankly a lot easier to just put a turbine in a bunch of concrete right there on the ground, et cetera. So it is less expensive onshore. Obviously in Europe, less land that's undeveloped, so they've kind of pushed offshore. I don't know the exact numbers for deep water, but I think it's $80, $100, if not a bit more, per megawatt hour for deep waters. We're thrilled that we will have, I think it's 30 megawatt plant, offshore plant off of Rhode Island. I think a couple of thoughts. One, it's great to catalyze that industry, to jumpstart that industry here in the United States. It will take a decade or so for their costs to come down as we start getting scale, both whether it's in the manufacturing, whether it's in the terminals, i.e. the shipping locations to move out, and the expertise. We do anticipate, and DOE's Wind Vision speaks to this, the costs to come down to be a lot more competitive. But that'll take a decade or so to happen. So that's on the cost front. Clearly on the other impacts, you avoid, for the most part, depending exactly where it is, some of the siting concerns. You can avoid some of the bird impacts, again, depending upon exactly where it is. So there's some trade-offs. I do think long-term it's a great opportunity given its proximity to the East Coast load, developing in the Atlantic, easy access to load on the East Coast.
So the question is, what's the impact of EPA Regulation 111D, and is it a sure thing, and what's the up and downside for the renewables?
Is it a sure thing? That's a good question. EPA is going to formalize and finalize the rule this summer. So I know they're going through how many million of comments in order to finalize it. There are several comments that were provided that we think are very important because they came from AWEA and SEIA, so hopefully they're listening to those. And what we also have now done is develop a document that we can give to states to help them in their implementation. I think there will be some legal challenges, but the Supreme Court has already ruled that EPA has jurisdiction to regulate carbon emissions. And so while you may have some groups who don't like it, who are going to threaten suing, the implementation is still going to go forward. You're still going to have some states that are going to resist the implementation, putting together implementation plans, but they have in most of the other environmental rules and regulations over the years, and subsequently have to pay penalties, or they get a standardized implementation plan put in place for them. The real challenge really, again, is that each state is going to develop their own separate initiatives in order to comply. So every state has a different level of reduction that has to be achieved. And so in addition to making sure the rule is accommodating as possible to technologies like solar, wind, and others, it's going to be each state implementation plan that we're going to have to affect that ultimately is going to judge what the market's going to look like. So, you know, when we step back and say, gosh, it's going to be really important, we don't know exactly what we're talking about in the sense of numbers of gigawatts. What we can tell you, though, is our comments are to ensure that renewable energy is considered a compliance technology. It's not just end of pipe, it's replacement, or you're augmenting your existing systems with carbon-free technology, thus lowering down your total carbon emissions ratio. And then obviously we're also looking from a solar perspective at all solar technologies, distributed generation as well as utility scale. So again, giving that flexibility for states, let's just say like Massachusetts, that doesn't have you know, either the solar resources or the land area to accommodate, you know, hundreds of megawatts of utility scale projects, but they do have the rooftops and the availability to accomplish their reductions through distributed generation, be it solar or whatever other technology. So what we view it as is a very long-term driver for renewable energy in this country, as well as other clean energy technologies. But we won't see that market impact probably until at least 2018 start to show up, and then beyond that. So the first targets are in 2020, and then beyond that in 2030. So some states who are already more aggressive in their renewable deployment have those earlier targets. But it's very difficult to quantify. Now, AWEA, I know you guys have done a lot of analysis on this. You may have a better sense as to what the actual megawatt implementation will be. But my sense is it's going to be as big, if not bigger, than the RPS requirements that got us to where we are today.
Yep. Agree with all that. The only thing I would add is we've heard from EPA, the 2020 deadline, they may, when they go final, slip that a bit. One of the major criticisms, concerns from utilities and others is, oh, we're not going to be able to comply by 2020. So we don't know for sure, but that may get delayed. And we'll see what they come up with midsummer.
And that's an issue that's going to affect all energy, you know, technologies and industries. It's going to be a huge, you know, I think opportunity, frankly, for everybody in this room, and for all of your companies. So view it more as an opportunity as we're kind of adjusting and shifting over the generation mix in this country rather than just a cost.
So the question is, how much are we seeing in renewables for heavy industrial, for either greening their power supply or self-sufficiency?
It's a great question. You're starting to see quite a bit more. General Motors is one of the largest consumers of photovoltaics, of solar in the country, and they have, I think, the largest rooftop system in the country, almost 10 megawatts. You see Toyota doing the same thing. You see BMW doing, so you see a lot of that starting to occur. And you're right, they have a huge amount, not only of roof space, but also of land availability. So you're seeing more and more, certainly in those companies who have either sustainability, you know, requirements or goals, or frankly are in states where they have high energy costs and they're doing it purely from an economic perspective. But you're also seeing solar thermal applications be used for some interesting enhanced oil recovery. So where you have, especially in California, kind of thick oil, they're using solar thermal to actually generate the high temperatures to extract the oil, which is different. You also see it in the mining sector. Solar, not as much in the United States, but certainly other areas has started to play a role in providing electricity for mining areas. Again, very difficult sometimes to generate the power necessary for these very remote locations. And so you're seeing more and more of that. I think in the long run, it is a great market segment, but it depends on how the rate structures exist for those heavy industries. A lot of times the utilities have given them very long-term, very low-cost electricity prices, so the economics may be much more difficult for heavy industry in the same area as it might be for commercial applications, just simply because, again, they're large users and they've entered into longer contracts with utilities.
If I can just, one other comment, just to add to Roan's good list on opportunities for renewables in both solar, wind, and others, data centers throughout the Midwest in particular, but there have been all kinds of announcements, whether it's Google, Microsoft, Yahoo, and others have been purchasing a fair amount of solar and wind, and it's just working quite well for us, and we see more opportunity there as well.
Great point.
I think the most recent announcement was Apple, and they've opened new data centers that have full-on solar fields, and they're buying big PPAs of renewable power.
If a residence or a commercial location is considering putting in solar panels, do you recommend that they contact their local fire department to see what their policies on roof venting? And if they won't vent the roof, what will be the impact on their fire insurance?
Good question. The answer is yes. We do encourage any of the building owners to coordinate with their local fire marshal, and most do. When you're putting solar up, you are going to get your fire marshal to come and visit. The venting, it really depends on the application and what works for the facility more than any kind of standardized effort. I think what we're starting to see, we have a good dialogue with kind of the National Fire Marshals Association about what is the right type of installation, venting, shut-off components, et cetera, and looking at both residential and commercial. As you know, it differs quite a bit. There is a new requirement that will be coming out from the NEC about module level shutoff. So again, this is protecting the firefighter so you don't have live wires if the fire is going on during the day, which again, we want to do whatever makes the most sense ultimately for firefighter safety. But I think on a state-by-state, or excuse me, a project-by-project basis, it's important for the individual company to work with their local fire marshal to understand and get sign-off really on that design. But I'm open to more suggestions. I mean, this is a relatively new issue in the sense of the amount of solar now starting to exist on rooftops. So if you've got you've got an idea about how we advance the conversation and look at new codes and standards that address this in advance, that's what we're trying to ultimately do, is be proactive and trying to figure out beforehand. The new NEC will have module-specific shutoffs. I know this is it's an issue we've been working with through the NEC process, trying to have a good open dialogue and find solutions not only for the National Electrical Code, but also for the fire safety codes as well.
So the question is, he's looking for a good tool to help him find some reliable installers, I think, for his local area for commercial and residential.
I mean, both of our associations are nonprofits, okay? So we're not selling you anything other than information, data, and ultimately trying to connect various aspects of the industry together to help grow an industry. So I would say certainly start at SEIA's website. It's just SEIA.org. And you'll get on and you'll find a lot of information about state-specific policies, obviously about the federal piece. You'll find a lot of information about the industry itself. I mean, if you're going to look for a company to work with, I would start with a company that's a member of SEIA. One, because they have to go through an ethics agreement to be a member of SEIA, so there's, in theory, at least a process internally where they're reviewing that, one. And two, they're probably more established and part of the industry, right, because they're part of the association. So we have very good lists there that I would start with. If for some reason you run into a problem, let me know. We've got, and if you're in Texas, we've got a big list of companies that we work specifically with in Texas that I'm happy to make available to you.
Yeah, I was on their site last night, and they have a good list of all the contractors, and you can do it by volume or location. So.
Same thing with the incentives that are available by state?
Yeah, there's not much in Texas, but there is a federal tax credit. So, but yes, we have a link, a connection to a group that's called IRIC. They have a website called dsireusa.org, And that's probably the best one to start with. I think it's still alive. But dsireusa.org, and that you can click on the state, you can find out their interconnection rules, you can find out their net metering policies, what rate issues might be up, as well as any incentives that might exist at the state, utility, and local levels.
Making smaller wind turbine good for backup for like smaller applications?
So that's a good question. So really the question is, the chart shows how wind turbines have gotten larger, but the question really is there a future for distributed generation, smaller wind turbines?
There are some applications and some development with efficient, smaller wind turbines. I will say, with the scale is where we've been able to get the costs to come down as rapidly as they have. So yes, there are some applications and some smaller turbines. They're going to be more expensive on a per kilowatt basis than the larger ones. As to the industry where we see it going, we do see continued growth in the size of the turbines. It will clearly, or in the height of the turbines, I should say, it will clearly max out at some point. But we're seeing in the next decade or so, it'll be another 10, 15 meters taller. So they are going to keep growing. And there will be some technological advancements for the smaller ones.
I have a question I could tag on to that. So in the solar market, there's this thing called community solar, where typically if you can't put solar on your roof, you invest in some sort of aggregated fund, and you can own a piece of solar somewhere remote from your house. Is there anything similar to that in wind?
Yes, there's actually a group that we work with, it's kind of a subsidiary of ours, on community wind. So there are some applications for it. Frankly, the solar side has worked so well because, and I don't know all the examples, but it is less visible. That's an upside of solar. While people may not be connected to it, they're not seeing it. When you have a community and a wind turbine right next to it, obviously there's some anxiety for some folks seeing it. As we were talking over breakfast this morning, I and many others see a turbine. I think it's actually very attractive. It's sexy. It's cool looking up at this thing that is spinning, creating electricity without generating any carbon, without using any water. I think it's great, but that's not for everybody, and so that's a bit of a problem for us, for community wind. We're obviously community solar, that's a lot less of a problem.
But Tom,
Sir,
you mentioned on your house, you get most of your electricity from wind, right? So as a consumer, at least, option, right?
Exactly. You can, I'm part of, Old Dominion Electric or whatever, and so on my monthly bill, I do pay a little bit of an increment, which is not the case for a lot of solar applications, to be able to be powered by wind, but I also don't, so I get that emotional benefit, but I don't get the benefit that you've got of, no, those are my panels, and here is my application tracking the electricity that I'm generating. So it's not as good as what solar's been able to do.
So you're saying wind's not as sexy as solar, Tom? Is that what I
No,
just heard you
I
say?
wouldn't. Now that's an overstatement. You've grown, you've got.
I couldn't resist, sorry.
There's no app for that. Go ahead. So the question really is how does technology impact the cost of solar, both efficiency and cost, which are related, so for both wind and solar?
You know what I didn't put up as a slide that shows how the average efficiency of modules has improved while at the same time the costs have come down. So there is a direct link to the cost savings in the solar industry based on efficiency gains that have been made in modules as well as inverters and balance of systems. And you have seen the average efficiency over that same kind of window where I showed you the price improve by about 50%. So, we're already seeing those gains. They're driven in large part by improvements in technology, improvements in manufacturing processes as well, improvements in feedstock materials and other things that have certainly made those gains. Now, looking forward, it really depends on the application. So you look at, large utility scale solar projects where you've got literally an unlimited amount of land, you don't need the higher efficiency necessarily. The higher efficiency, higher perhaps unit cost product, you'll go with something lower because, again, you have so much land. But then it balances out with the racking systems. You need more racking. So it's really, it really depends upon the individual application, the location. Certain product is going to perform better in the Northeast than it will, for example, in the Southwest, as well as, obviously the other costs that are associated with it. But we're seeing continued improvements by the manufacturers on all of the product levels. You see a new record come out of a laboratory around the world literally every 3 months or so about a new higher efficiency cell. The biggest cost savings or efficiency gain that has been made that's resulted in the cost is just the scale of manufacturing. And a lot of that had to do with the German market, which was viewed very stably and allowed companies to invest in larger and larger manufacturing facilities, including the Chinese, who then produced, the gigawatt size manufacturing plant where the largest had only been maybe 100 megawatts or even 50 megawatts before. So that scale of manufacturing has really had a big impact on the cost, but also allowing us to improve the efficiency because so much of this, the systems are automated and very high tech.
One quick point I wanted to make is to the integration of solar and wind. One recent example in California, the California Grid Integration Study came forward with an analysis that showed actually, obviously solar during the day, extraordinary production, wind throughout the day, but often at night is when you get more wind. So you combined solar leading the way during the day with some wind, and then at nighttime, no solar, but wind's kicking in. You combine that with some gas. Boy, the combination of wind, solar, and some gas, that's a pretty carbon efficient, effective mix of renewables with gas, and we're seeing that happen in California, and I think can happen elsewhere throughout the country.
Another thing in efficiency, and I'd encourage you, and I'm going to give a little ABB plug here, if that's okay, to go over and take a look at some of their solar products, and specifically the improvements that you're seeing in the efficiency exists in many ways in some of the new add-ons, if you will, the ability to monitor how each module is performing. And I know ABB now has an ability to look at the modules, and it's all wireless, and you can pull it up on an app, and so you can see the performance. But then what you can really do is identify where there are problems that are potentially happening long before you're noticing it in your bill or you're noticing it in some kind of monthly statement. And I think that's kind of one of those improvements in the sense of operational efficiency that new products from ABB and others are starting to provide that make it really hands-on. I mean, Tom talked about the app, and I've got an app on my phone, which is really neat. You can see how the system's working. That's only going to continue to improve. You're going to see more systems with homes and businesses that show how your consumer consumption is taking place. And so you can really improve the efficiency based on that data. I mean, I'll just give you kind of a very simple sample, which is when I put my solar system up, I used a system called Fat Spaniel. I'm not even sure if they're around anymore, but it was a monitoring system.
Yeah, they are. ABB
Are they?
bought them, yes.
Is that right? All right, well here's another plug for ABB. Ready for this one? It did both the generation as well as the consumption of electricity. And it was fun to see how the solar panels were working. But what was really frustrating was to see how much energy I was consuming and couldn't really figure out why. But now I had a data source that allowed me to go around and start improving things, unplugging things that didn't need to be plugged in, making sure things were on power strips when I needed, if I need to do that, just really improving the efficiency. So I went from a standing about 2 kilowatt, not quite 2,000 watts of just standing electricity consumption down below 500, so about 450 just standing. And that's, the refrigerator's still plugged in, my beer's still going to be cold, and, I'm not sacrificing life here. I'm just, really improving the efficiency, again, based on that data source that I had, which was this monitoring system. So those are the kinds of things that can really improve the efficiency, not only of your solar panels, but ultimately of the performance of your house. And that's the kind of improvements you're seeing that ABB's bringing out and others. It's great.
So that question kind of set the stage for something else, if I may, for a second.
Just text your children, have them turn off the lights.
Well, you'll love this. So I spent a lot of time on the Hill, and I bring my app with me. We go in to meet with a senator, and my father-in-law had moved in with us for a while, and he's from Florida. He was walking around with a space heater, right? And so the air conditioner would be on. He'd have the space heater. The washer dryer would be going. I'd be looking at it like, what the hell is going on in my house? So I'd quickly call my wife and be like, hey, you got to shut everything down before I get in there with, Senator whoever. True story.
But your efficiency technology question was interesting because where we're at, both I think in wind and solar, they've expressed their points is that it's very competitive with traditional power in many places. So really the question is, as we have difficulty I think with certain utilities in certain areas, I think the main argument right now is it's costing me money to put that on my grid. How do I recoup those costs? That conversation is going to shift as storage becomes less expensive. So the question really is, and I'm opening the question to both of you, is how do you see storage playing? When do you see storage? And is it going to make life better for you and the relationship with the utilities as we go forward?
I'll take a quick crack. Clearly see an opportunity for storage out there, obviously at different scales in different places, whether it is it was your CEO this morning when he was speaking, I think he showed a slide on Kodiak Island, and so, some examples like that, or other Alaskan villages, or out in Hawaii, as well as applications on a main grid. So you're going to see storage, you're going to see more of it. So it's a great market and there are needs there. I would say, let's not forget, the grid itself is a storage device, fundamentally, because obviously you've got all kinds of different energy sources attached to the grid, and in a way, a natural gas plant sitting there idle is a storage device. It's sitting there with a bunch of gas ready to kick in as needed. So there is a chunk of storage already on the grid. There will be more coming on when my understanding from our members, about 1,000 members of AWEA, when they're working with utilities, there are some applications where we're talking about storage, but a lot of times it's just the pure cost, and low cost and guaranteed price of wind that is most attractive to the utilities, and they're just buying it straight up for that reason, and given the coming Clean Power Plan and the need to reduce their carbon emissions.
Yeah, storage is here. It's just expensive and not widely used. But there's a couple things that are, I think, fundamental game changers with respect to storage and its application. So I talked about net metering and how we're battling back and forth with the utilities on that. We won't need net metering once you have storage, right? You'll be able to put all your extra electricity into a battery pack, and then what I've done is I've reduced my electricity load by 90%. And it's just the same thing as if I'd used efficiency technologies to get there. And I'll still be connected to the grid, but I'm only be using 10%. So that's nice. When's that going to happen is the question. What's I think starting to develop is some large-scale investment in storage and residential and commercial storage. So you're looking at the gigafactory that Tesla is going to produce. I think that's great, and it's along with Panasonic, and ultimately it's Panasonic's lithium-ion technology that we're talking about. But I went to Amory Lovin's house, who runs Rocky Mountain Institute, and he has a big battery system to back up his solar system because he lives in Colorado. And his battery system was, the size of somebody's dining room. I mean, it was big. It took up a lot of space, a lot of lead-acid batteries, a lot of maintenance, all the rest. You get that same type of storage. You can get an 85 kilowatts, almost twice as much storage than what he had on a battery pack that goes in the Tesla that will hang on your wall, be about 5 inches thick, and you can put it in your garage or wherever else. So it takes up zero space in comparison. So some of the issues with respect to maintenance and storage and area and all the rest of that are going away very rapidly. Ultimately, the question is about cost. When is that cost going to come down? And I think it's going to be electric vehicles that does it in large part. And I think you're going to see electric vehicles be that storage option. So I have an electric vehicle. I plug it in when we have a lot of sunshine on our house, and I'm charging my car with electrons from my solar system, which is a pretty cool thing to do, but it also becomes that storage piece, right? So instead of using it or charging at nighttime from coal or whatever it happens to be, I'm using the electricity from the sun to store. So I think that technology is going to happen very, very rapidly. Again, you already see the automation of these electric vehicles, so you can you can adjust when you're charging your car. You plug it in all the time, but you adjust it. So you are like, I just want to charge the car from 9 a.m. to 5 p.m. when I'm getting the most of solar, or when or midnight when the rates are lower, or whatever it happens to be. So I would say that the technology is here. It's going to be cost effective. You guys probably have a better sense than I in 5 years or so. And there's going to be a lot of pressure to bring the cost down from a large-scale manufacturing very soon. It's exciting.
So the question really is, again, around community wind and smaller wind, and what are your thoughts going forward?
There clearly is some growth. I don't see the dynamic growth for community wind that you're either seeing for utility scale wind or for solar. I do think there are applications, whether it's small communities, schools, where there's an educational purpose to it, but so I think it's a small market and will remain a small market.
So to sum up the question, I think is, do you see us coming to the point where we're exhausting our onshore options and we need to go offshore?
Great question, and you may remember the Wind Vision chart, that dark ramp up that I showed. That does actually have a fair amount of onshore repowering, because come 2020, we'll start seeing the 1990 facilities be repowered. So we see a lot of onshore repowering. Wind Vision does project of all the wind, 3% offshore, of total wind, 3% of that would be offshore by 2020. So, I mean, I think in the United States, it's exciting seeing what offshore is happening. I think for the foreseeable future, and at least DOE's Wind Vision projection out to 2050, offshore in the United States will still be relatively small. We're going to be repowering onshore, and there's still a whole lot of land left to develop for onshore wind in the United States. It's, you know, less expensive, so I think offshore will grow, but it'll still be a small percentage relative to total wind in the U.S.
So the question is, outside of Europe, is there a larger market for offshore wind?
I believe there's some offshore sites. It was either off of Japan or China. So I think it was off of Japan. They just installed some, but that's the only other place I know of. So it's mostly Europe. England, UK as well has a fair amount of offshore wind.
So I'm starting to see some people leave, so I'm going to put in a shameless plug, all right? So we have another wind session tomorrow, and then we have a solar session on Thursday in the morning. So just remember to look for those, and then we'll continue with the questions. We have until 11:30, so there's no rush. So the question, and it's a good question, so because they're different, I know for a fact. Access to transmission, how does that impact both wind and solar?
You may be the better one.
I will say it's a bigger issue for us, I think, than for you, but you go.
Yeah, it's a big issue for our utility scale. There's no doubt about it. It's interesting. The DOE went out, the administration went out working with the Department of Interior and created these solar study zones, these specific areas that were going to be developed on federal land for utility scale solar projects. Great resources, favorable land conditions, minimal environmental concerns, but there was no transmission. So I was like, hey, great, when are we going to build these? So there are 0 projects being built on these, federal solar zones because of that very issue. And so it affects, certainly some of the best resources we have in the world are in the United States, but we can't get access to them. But yet there's also other opportunities when you look at where wind exists in Southwest Texas, and the complement of when solar can be applied, use the same transmission lines because we don't necessarily generate electricity at the same time. So you're seeing some of that development occur based on the leadership that the wind industry had in developing those areas. But in the long run, it's a big constraint, Chris, and it needs to, we continue to work on transmission issues together, but it needs to happen faster. We need to build more, and it needs to be targeted to these areas that have such great resources.
Only thing I'd add, DOE's Wind Vision does lay out the need for, I think it's 900 miles transmission each year for the next 10 years. It's roughly the rate of transmission that we have been developing, but it is critically important. It's needed to be able to get wind from, rural communities, whether it's in Texas, Iowa, Kansas, to load. We do need more transmission. And that's a challenge for the industry, and thank goodness we've got companies like Clean Line here in Houston that are developing additional transmission, but we do need it.
And I can comment on that a little bit as a technology provider. So the advent of the smart grid, I mean, it's not a one-way line anymore. So with the help of the transmission provider or the utility, we can do some analysis and figure out what the flows are, optimize the technologies to make sure that you're getting the right amount of power through there, that you're cleaning it up so you don't have bars that are maybe wasting space, things like that. And then you can also rerun a line so we can go to a higher transmission technology like HVDC, depending on the distance. The economics comes into play in the load. So it doesn't always have to be a new line. It can just be optimizing existing assets. It comes down to who's incentivized to do what. So the question really is there any plans to do cross-national transmission planning?
And the reason for that would be our ultimate battery.
Yeah, I think really talking about a larger grid. I mean, we're in a unique location in North America, right? So we have a couple different isolated grids within the U.S., and then the question is, can we string into Canada and which we do already in the Northeast and then into Mexico.
There are some, is it, National Grid, I think, was doing it. There's a connection from Canada down to the Northeast to bring more hydro that's being proposed. But that's the only one that I know of.
And there's been a number of projects that have looked at how you use superconducting lines to move huge amounts of electricity from the Southwest, where you've got these great resources, these solar resources, up to the populated areas of the Midwest. But none of those have actually turned into practical plans, let alone something international. There was, Chris, remember this, the Northern Africa, European,
Yeah.
the Desert Tech.
Desert Tech, yeah. Yeah, ABB was involved in the Desert Tech initiative at one point, and the difficulty, as I recall, was you could get a huge amount of solar renewable power out of Africa into Europe, but the problem was getting it from your entry point into Europe onto an existing aging infrastructure that's big enough to carry that capacity, and that's where the whole plan wasn't flushed out, I don't think.
Seemed like a
So it
good
always becomes a local issue, right? I mean, you can bring it in, but then what do you do with it?
Exactly.
Then you have your brand new 500,000 volt cables.
Yeah, there you go.
That's why we were part of the group. Do we have any other questions? I think we're getting close to our time limit. Yeah, we have 5 minutes still, so feel free. So the question really is, what's the payback on a solar system? And I actually have some experience too, but I'll let Ron handle the question. But just a clarification, $20,000 was the average cost, but not necessarily, yeah.
Yeah, that's a 6 kilowatt system, kind of the average size system, looking at $3 and change for the average install cost. It doesn't include the tax credit. It doesn't include any local incentives. So that is just the, typical, what would it cost today? You do get a 30% tax credit. So let's say it's 20 grand, so you're going to get 6,000 off there. If there's any local incentives, you would take those first. But the point being is the average install cost ends up being closer to 10,000, 10 to 12,000. One, if you're going to purchase it. Two, there are often mechanisms that provide kind of a, let's just say, performance benefit over the long run. So they're called renewable energy credits, or solar renewable energy credits, SRECs, which you can then sell in the marketplace in many of the states. That's what we do in DC. We sell our SRECs. And just to kind of give you a sense, DC's market's a little bit unique, but it exists in a lot of the other Northeast states as well. We get about in fact, we just got it last week, a $4,000 check for selling my SRECs into the marketplace. So we generate about 10 megawatt hours, and so we get 10 SRECs to sell. So, that becomes part of the factor in how do you look at the economics and the payback. And, again, if you were doing the same system today and you put, let's just say, $12,000 in, your SRECs alone, at least in my neighborhood, would pay for the system in 3 years. You then, look at other areas, New Jersey perhaps, where they don't have quite the value of the SRECs anymore, and you're looking at a 6-year payback typically. So it still makes a lot of sense to actually buy these systems, but if you don't have the cash up front, that's where the third-party ownership, the lease model, or even a PPA for residential systems can make a lot of sense. And that's why you see in states like Arizona, Nevada, Colorado, the lease is about 80% of the market. So people have really embraced that, and it keeps the cost low up front for sure.
Yeah, and to simplify his answer a little bit, just if you get multiple installers to give you a quotation, they'll typically give you a pro forma. They'll look at 2 years worth of your energy bills, they'll do an analysis, and they'll project what your ROI is over a certain period of time, so you'll see your payback on a chart. It's very, they've laid it out in a methodology that makes sense to just about any. So if you're a business person generally, and if you look at it as an investment, it'll translate it to an ROI, and I think on my house it was roughly 12%. So you find a place where you can put $12,000 and make 12% guaranteed, it's, then buy it.
Good answer.
But I was in California, so the rates are significantly higher. So that's your issue.
Quick question.
Yes, sir.
Where can you get the information about all these incentives?
Yeah, so I would say just start at the SEIA website. It's a little easier to remember, just SEIA.org, so SEIA.org. We have links in there to a number of different sites. One of the better ones is called, it's IREC, it's Desire, DSIREUSA.org. It's a mouthful. So start at SEIA, it's a little bit easier, and then you can decide, specifically what state you want to look at, what utility district, et cetera. Most of that information is all available there.
Thank you.
Sure. The one thing, since I see no more hands up, that I would encourage everybody to consider is, as you're getting into the solar and wind business, where do you continue to get this information? Where do you find opportunities to network with other companies? How do you get more clients, et cetera? And that's where our two associations play such an important role. So SEIA, again, as the National Trade Association, we do a couple of things, one of which is we're member-based, so we ask companies to join us. So we're advancing the policies that help you grow your business. We also run two conferences, actually more than that, but one called Solar Power International. That's taking place in Anaheim in September. We'll get about 15,000, 16,000 people from the solar industry all together, and it's a great way to see the technologies, meet companies, et cetera. It's really kind of the coming together of the industry. We then run another one called PV America, which is a smaller show, and that's going to be in Boston on Monday, actually this next week. So I would encourage you certainly to kind of consider going to those events as well. But I know I speak on behalf of Tom and myself when I say that you should join our respective associations, because we're only as good as the companies who show up and participate. One, we need to make sure we speak for the entire voice of the industry and that we're getting you the information that you need. So one, we can develop it and learn it. But ultimately, we need to advance policy. And by having the industry's support within the association, we're going to be better capable of doing that. And you look at the big associations out there in the energy industry, like the American Petroleum Institute. They are a very large association that has a budget in excess of $200 million a year. Just to give you a sense, SEIA's budget is $8 million. And we've got to do federal policy, we've got to do state policy. We're talking about net metering proceedings in 20 different states. We're dealing with a trade issue with China. We've got all sorts of individual issues on fire codes and safety and all the rest. So it's so important, frankly, that the industry does participate and become part of our two associations. So please consider that as you walk away, and take a look at our website for more of that information you're looking for.
Good summary.
All right, so
Boston, as in 10 feet of snow.
yeah, you may want to rethink that one in the future.
Come on up.
So let's thank our guests, Tom and Roan, for coming today. Appreciate the attendance.
Always a pleasure.
If you have questions in the future, you can reach out to myself or Dennis for contacts, and we'll help you out. Thank you all.